This is SpaceTime, Series 28, Episode 13, for broadcast on the 29th of January 2025. Coming up on SpaceTime, mystery mounds revealing the history of water on the red planet Mars. Could the Earth's moon really be a chunk of the Earth ejected into space? And establishing a permanent presence on the lunar surface. How hard could it be? All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has shown that thousands of mounds and hills on the barren Martian northern plains are full of clay minerals, providing clear evidence that these rocks were once soaked with water. The findings, reported in the journal Nature Geoscience, supports the hypothesis that the expansive red planet northern lowlands was once the floor of a vast Martian ocean. One of the study's authors, Joe McNeil from the Open University, says these mounds are all that's left of a landscape roughly the size of the UK that's been almost entirely eroded away. McNeil and colleagues used high-resolution images and compositional data captured by orbiters around Mars to better understand the geology of these mounds. They found that the mounds, which are up to half a kilometre high, are all that remains of an ancient highlands region, which retreated by hundreds of kilometres after erosion wore away the terrain billions of years ago. These actions played a key role in shaping the Martian landscape, which divides the planet's low-lying northern hemisphere from its much higher southern hemisphere. The mounds are made up of layered deposits containing clay minerals formed through water interacting with rock over millions, maybe billions of years. These clay layers are sandwiched between older non-clay layers below and younger non-clay layers above, marking distinct geological events in Martian history. McNeil says the mounds are incredibly exciting because they preserve a complete history of water in this region with inaccessible, continuous rocky outcrops. And that makes them a prime location for future missions aimed at uncovering whether Mars ever had an ocean and whether life could have existed there. Remember, here on Earth, wherever we find water, we find life. The study also reveals that these mounds are geologically linked to the nearby plains of Oxyaplanum, which the European Space Agency Rosalind Franklin rover is set to explore in 2028, looking for signs of past and present life. By piecing together the red planet's ancient past, scientists are uncovering the story of a planet that may once have been capable of supporting life. In fact, many scientists see Mars as a model for what the early Earth might have looked like. And the lack of plate tectonics on Mars means that much of its ancient geology is still in place. So by studying Mars, we learn more about our own home planet as well. This is SpaceTime. Still to come, could the moon have been created by an ejected chunk of the Earth? And establishing a permanent manned base on the moon, how hard could it really be? All that and more still to come on SpaceTime. A new study claims that the moon was created out of the Earth's mantle. The findings, reported in the journal The Proceedings of the National Academy of Sciences, also supports the idea that water could have reached the Earth early in its development and may not have been added later by asteroid or comet impacts. Evidence from rock samples brought back by the American Apollo Man-Moon missions and studies of early Earth geology both suggest the best hypothesis to explain the birth of Earth's moon 4.5 billion years ago was a giant impact. Now, this theory suggests that a Mars-sized planet named Theia, possibly even an Earth Trojan, slammed into the early proto-Earth about 62 million years after the birth of the solar system 4.6 billion years ago. The timing is based on measurements of tungsten isotopes in lunar metals. This cosmic collision melted both bodies, turning the lot into a giant magma ocean floating in space. Theia's dense iron and nickel core coalesced with that of the Earth. Now, at the same time, vaporized debris from Theia's lighter silicate mantle and crust, together with material from the Earth, was ejected into space, eventually orbiting the Earth as a ring before slowly coalescing into the moon we see today. Being composed mostly of silicates neatly explains why the moon's not as dense as the Earth. But now, researchers have discovered another piece of the puzzle, the formation of the moon, and also how water reached the Earth. The new measurements indicate that the moon formed from material ejected from the Earth's mantle with little contribution from Theia. The authors analysed oxygen isotopes from 14 samples from the moon and carried out 191 measurements on minerals from Earth. They used an improved version of laser fluorination, a method in which oxygen is released from rock using a laser. The new measurements show a very high similarity between samples taken from both the Earth and the moon of an isotope called oxygen-17. Now, the isotopic similarity between the Earth and Moon is a long-standing problem in cosmochemistry for which the term isotope crisis has been coined. One of the study's authors, Andreas Pack from Groningen University, says one explanation is that Theia lost its rocky mantle in earlier collisions and then slammed into the Earth more like a giant metallic cannonball. Now, if this were the case, Theia would be part of the Earth's iron core today, and the Moon would have formed from ejected material from the proto-Earth's mantle. Pack says this would explain the similarity in the composition of the Earth and the Moon. And the data obtained also provided an insight into the history of water on Earth. The widespread assumption is that it only arrived on Earth after the formation of the Moon, most likely through a series of asteroid and comet impacts known as the Late Vernier event. As the Earth was hit much more frequently by these impacts than the Moon, there should also be a measurable difference between the oxygen isotopes, depending on the origins of the material that impacted. However, since the new data shows that this isn't the case, many types of meteorites can now be ruled out as a possible cause for the late Vernier. Instead, the data can be explained by a class of meteorites called enstatite chondrites, which are isotopically similar to the Earth and contain enough water to be solely responsible for the Earth's water formation. This is SpaceTime. Still to come, establishing a permanent presence on the Moon. How hard could it be? And later in the science report, a new study warns that coral bleaching on the Great Barrier Reef has now reached catastrophic levels. All that and more still to come on SpaceTime. NASA's Artemis program is aimed at returning humans to the lunar surface after a break of more than half a century, and this time maintaining a permanent presence there. The idea is that eventually the Moon will provide a jumping-off point for manned missions to Mars. But building a permanent man base on the Moon will involve lots of planning and lots of innovation. Establishing a human habitat on the lunar South Pole, on an airless, dusty, radiation-soaked rock thousands of kilometres from Earth, is doable with today's technology, but that doesn't mean it's going to be easy. Now, a review of the plan by Concordia researchers, reported in the journal Progress in Aerospace Science, breaks down the many challenges of lunar-based manufacturing and construction, which will be essential for establishing a sustainable long-term lunar presence. To establish the infrastructure needed to produce the essential tools, structures and systems for habitation on the Moon will require three critical technologies. Firstly, there's 3D printing, then there's extensive use of robotics, and finally, lots of artificial intelligence to solve problems in new ways. One of the study's authors, Krzysztof Skaninski, says these three technologies working together offer the versatility, adaptability and flexibility needed to respond to the challenges as they arise. A 3D printer will be able to produce specialised parts and structures essential to building, maintaining and repairing lunar infrastructure. Given the unique environment in which they'll be used, many of the instruments will be equally unique. In fact, for everything that needs to be built on the Moon, it'll probably be the first time, and it will need to be done based either on inputs from the crew on site or from specialists on the Earth who can beam up designs, have the machines produce them while the astronauts are asleep. The Moon also has a critical natural resource that can help cut down the total payload from Earth-launched supply missions, namely the lunar regolith, the layer of fine but highly abrasive dust which covers the Moon's surface. And so there'll need to be a mobile 3D printing robot that uses a composite of space-grade polymers known as polyether ketone and a lunar dust simulant for on-demand fabrication of complex geometries. And of course, regolith has the additional benefit of being an effective barrier against solar radiation. So using it in construction as a radiation insulator layer would reduce the need to bring similar materials up from Earth. The longer-term challenge will be transitioning towards using local materials on the Moon, primarily not just as a filler, but as the main ingredient. However, current solutions for this are all very energy-intensive. Both the United States and China have stated their ambitions to establish long-term presence on the Moon by the middle of the next decade. Konietzki says the goals are feasible for similar and shorter duration missions along the lines of trips to the International Space Station or Antarctic research centres. He says a longer-term presence will present even more challenges, especially regarding the effects extended duration has on human biology, as well as legal issues around lunar territorial rights.
One of the challenging things about building on the moon is that you don't want to bring large infrastructure with you. And it's also challenging to bring humans. So ideally, what you'd like to do is use small robots that can move around and do the building.
Successful integration of robotics, additive manufacturing or 3D printing, and AI is essential for lunar fabrication. Robotics help us to fabricate large-scale parts in harsh environments. AI helps us to enhance decision-making, optimize the design, and monitor the processes.
Working on the moon is nasty business because you have to deal with the regolith that is there. You have to deal with the temperature fluctuations, the harsh vacuum environment, and the reduced gravity. And you have to get the materials there, both your building materials and the machinery to build it, which is one of the most difficult and most expensive challenges. Lunar regolith is a nasty, jagged, abrasive material which makes it difficult to work with and introduces engineering challenges to integrate into any process. On the other hand, using the material is a great way to reduce the costs of exploration. Additive manufacturing, whether it's on the moon or here on Earth, is advancing rapidly and is enabling us to combine high-tech materials in very novel ways.
That's Christoph Konietzki and Mohamed Azami from the Concordia Institute for Aerospace Design and Innovation. And this is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study has warned that adults diagnosed with attention deficit hyperactivity disorder, or ADHD, may have shorter lifespans. The findings, reported in the British Journal of Psychiatry, are based on data from 30,029 adults across the UK who have all been diagnosed with ADHD. They then compared this group with 300,390 participants without ADHD who were matched by age, sex and primary care practice. The authors found an apparent reduction in life expectancy for men with diagnosed ADHD of between 4.5 and 9 years, and between 6.5 and 11 years for women. More disturbingly, the study also found that fewer than 1 in 9 adults with ADHD had actually been diagnosed, meaning that only a fraction of the total population of adults with ADHD could be studied. People with ADHD experience differences in the way they focus their attention. They often have high energy and an ability to focus intensely on what interests them. However, they may find it difficult to focus on mundane tasks, and that can lead to more impulsiveness, restlessness, and differences in planning and time management. And that makes it harder to succeed at school or at work, leading to longer-term challenges. New research warns that the cycle of coral bleaching on the Great Barrier Reef has now reached catastrophic levels. The study by scientists with the University of Sydney highlights the complex interplay between heat stress, disease onset, and coral mortality. The authors found that 66% of the colonies were bleached by February 2024 and 80% by April last year. And by July, they found that 44% of all bleached coral colonies had died. A new study has found that blue rings in the stems of trees and bushes in Norway could have been the result of volcanic eruptions in Central and South America. A report in the journal Frontiers in Plant Science studied Norwegian pine trees and juniper shrubs dying wood samples to reveal blue rings, which represent years when the plant didn't grow properly, likely due to especially cold summer weather. The authors found that across the plants they sampled, blue rings were most common from the years 1902 and 1877, with 96% of pines and 68% of juniper shrubs revealing blue rings in 1902 and 84% of trees and 36% of shrubs in 1877. They say previous research had already linked the cold 1902 temperatures in Scandinavia to the volcanic eruption of Mount Pelée in the Caribbean. and the cold summer of 1877 aligns with the eruption of Cotopaxi in Ecuador. Well, it's been a huge week in technology with Samsung releasing its new AI smartphones. With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
Yes, well, there's three models, the S25, the S25 Plus, and the S25 Ultra. Obviously, the Ultra is the most advanced model with the bigger screen and the best cameras and the stylus, but all of them have the Snapdragon 8 Elite for Galaxy. So this is a specially fine-tuned processor. They're talking about a boost of 40% in the neural processing unit, 37% in the CPU, and 30% in the GPU compared to the S24 generation. And what Samsung is doing is they're promoting this as your AI companion. So I've seen this phone, I've played with it at a special event for the media, and you can talk to the phone like it was a human. It's using Google Gemini, so Bixby, which was Samsung's previous AI assistant. It's still there, but it's no longer the prime AI companion. It's now Gemini, and you can talk to Gemini in the same way you can talk to ChatGPT and discuss ideas and issues and reason with it. So that puts it ahead of what Apple is doing. It brings it to par with what Google is doing because Google has had Gemini. And look, existing users can download Gemini and use it too, but this is now sort of a standard part of the phone. You can ask your phone to look at a YouTube video, extract whatever are the main points and put it into a note in your Notes app for you. So the whole idea is it's becoming this agentic AI device where you can interact with your phone and get it to do things across different apps. Now, at the moment, it's the apps that are built in, the calendar, the Gmail, Spotify and WhatsApp are a couple of apps. I mean, there'll be more of them to come, but there's a thing called Now Brief that shows you information on, when you have to leave for your next appointment or things that you have scheduled for the rest of the day, other interesting information that is like a briefing for you. And you have this, when you look at the phone, it's on a lock screen as well. You've got call recording and transcripts. You've got the ability to translate 20 different languages on device. Samsung has been very strong in pointing out how much it's taking privacy very seriously. Being able to interact with the phone to ask it to dim the screen because your eyes are tired is something you can now do just by asking. There's a feature called Best Face, a little bit similar to one we saw from Google last year, where you can take a series of photos of people at a party or at an event, and inevitably somebody is going to be blinking or looking away or not smiling, and you can now choose from all the right faces and choose the best one so everyone looks their best. And I asked Samsung, is this just Google's feature or is this your own? And they said it's their own feature, which is interesting because good for competition. There's an audio eraser. So let's say you're recording a video and there's wind noise or there's just too much background noise, or you're at the beach and there's noise from the ocean. You can actually turn various elements of the background noise up or down. So you can focus on the voice or you can focus on the noises of nature. So that's giving you some video editing capabilities. If you have a bunch of Samsung appliances like one of their watches and a TV, maybe air filters, the watch can figure out when it is you've fallen asleep because your breathing patterns change and other things change, and it can turn the TV off for you, or it can put on the air purifier if it needs to do that based on what it's figuring out about your personal health metrics.
The other big question, of course, is price. I understand they've gone down in price compared to previous models.
Yeah, well, a few things have gone down. So it's thinner, it's lighter, it's stronger with this Corning Gorilla Glass 2. Now, last time you could drop it from waist height to a meter. This time you could drop it from head height, 2.2 meters, without a case. And according to the test, the screen hasn't broken. Now, the S25 Ultra starts for the 256 gig model in Australian dollars at $2,149. So that's $50 less than last year. And they've also got a 512 gig and a 1 terabyte model. It's $2,349 for the 512 and $2,749 for the 1 terabyte. Obviously, the S25 and the S25 Plus are cheaper with smaller screens, but usually the Ultra is the particular one that they want to sell. They teased something else. It was called the Samsung S25 Edge. So this is a very thin phone meant to compete with the rumored iPhone 17 Air that's meant to come in September or October this year from Apple. They've just gone all out to make this the best Android phone you can get, even better than the ones from Google, and they're hoping that this is going to propel them into winning the AI race for 2025.
That's Alex Zaharov-Reutt from TechAdvice.life. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.